Alrighty, day 10. So, did we start on 6? No, we started on 7th July. So, today is 16th, it's 10th day. And if you saw yesterday's video, we did 2D arrays and matrices and whatever. So, now it's time to do some practice questions for matrices. And by the way, we are early today, as I was hoping that we will be. And yeah, I was doing some other work, basically of that project that I'm mentioning again and again. But then I thought that there's like still an hour left. After that, I'll go for a walk or something. So yeah, till that time, I'm just hoping to get done with these questions and then do my remaining work in the night, because again, as I'm mentioning and as you are seeing, I'm getting sleepy in the night, so it's kind of getting difficult for me. Import java dot util dot everything. Let's say public class matrices pa, and let's just public static void main with string args. Okay, we are good to go. So the first question is that print the number of sevens that are in the 2D array. So if like okay, let's just make that array here. Let's say matrix key, which will be equal to, let's just, so it is 4 7 and 8, and also 8 at 7, 8 8 7, sorry 7. So yeah, so that's the matrix. Okay, I think that's fine. And so there are two 7 here, and so the output should be like 2 or whatever the count is. So let's just say public static int print num, let's just say, and it is having an argument as matrix. Do we need to give the key? Yeah, I think let's do it. So like the normal solution will be to just brute force our way through as usual. So let's just first do that. Int I is equal to 0, 0 I should be less than matrix dot length and I plus plus, and we can run another for loop which will be j is equal to 0, j is less than, okay, j is less than matrix 0 dot length j plus plus. So if a matrix of I and j, what is happening with me, yeah, is equal to key, let's say cow, okay, maybe just let's define count is equal to 0, So we can do count plus plus here. Then I think we can just return the count if I'm not wrong. Yeah, that should be it, right? Anyways, let's check. Let's say system number of occurrence of 7, and let's say matrix 7. So which we should get the output as let's say Java matrices pa.java. Okay, yeah, my bad. Okay, wait, what is the issue here? Public static. Okay, static, not stake. Okay, there is again an issue which will be we have semicolon here, right? Okay. Sorry, I have not initialized it. Okay, we can just take it here. Let's say here. My bad about that one as well. Okay, now it should be okay. It is working fine. If we say, let's say 8, so let's just change this to 8. Okay, but that would have the algorithm or whatever the time complexity as big of n square. Although okay, so I think there was a better way to do this. I am not really sure where was it. And I don't remember it actually, so I'll have to see here. Okay, but I do remember there was a better way to search as well. Okay, so let me think about it. Basically what we can do is I'm not really sure, to be honest. It was here, wasn't it? That's the normal thing. Okay. Anyways, let's move on to, or maybe we can see the solution for this one. Only this one. Okay, so basically there is not like anything special about it. They have just they have done the same thing by running 2 of the 4 for loops and then just comparing it with the 7. Okay, so yeah, that's it for the first question actually. And okay, so the second one says that just a second, why my laptop is fuming. The fans are working fine of the cooling pad if I'm not wrong. Okay, I think because I'm not wearing headphones, I'm hearing more noise. But anyways, let us move on. It is public static. So what do we need to do? We need to print out the sum of the numbers in the second row of nums array. Okay, so I think we can give again print that was num and now it is sum. What a fucking coincidence. Anyways, that's defined. Let us just change the matrix here. It says 1 4 9, then 11 4 3, okay, 3, and then there is also 2 to 3 in the last line, so it is 2 2 3. So according to this, our our output should be 18 because in the second row we have 11 4 and 3, so that's easy, that's equal to 18. So okay, I think we can just so we don't need to iterate over the number of rows or anything. We are given that we need to print out the sum of the numbers in the second specific row. So we can just say what can we say? Okay, so I was gonna say that if row number is equal to like 1, then just iterate through all the elements of that row and then print them. But how do we specifically get the second row? So matrix dot length. Okay, let's say if I is equal to 1. Okay, sorry. And for int j is equal to 0 and j should be less than number of columns, which is matrix dot 0 dot length, then we should do j plus plus. Okay, and we should okay, so can we just initialize and sum here, and then we can do sum is equal to matrix of 1 and j. Okay, so yeah, I think we don't need this if condition, right? We can just put 1 here and that will be it. It will not do anything else. So and return sum. So I think that should be it. Let's say sum of elements in the second row is print sum of matrix. We are not giving a key. Let us remove this. Okay, we removed that bracket as well. So yeah, that should give us output as 18. Yeah, and if we want to print 0th, then what will be? It will be 14. And if we want the third row, then we can just give second index here, and that will be 7. Okay, sorry. Yeah. So okay, so I think that's it. Okay, we'll check the solution for that later. or maybe we'll just check it. Let's see. So yeah, that's it. Let's just make it 1 here again. So and they are not creating any functions or anything, but I'm just doing that extra work because then I would not have to like clear things from main functions again and again. So yeah, that's just better. Anyways, now we have to do. Okay, so if you felt like those two were easy level questions, they actually were. But now comes another question, which is, I think, a bit difficult. But okay, we'll see. We will see what can we do, brother. Public static void transpose. So basically, what we are doing is that we need to write a program to find the transpose of a matrix. Now, what is transpose? If you have not learned about it, let me just tell you. Transpose of a matrix is a process of swapping the rows to the columns. So, for a 2 comma 3 matrix, which will be like 2 rows and 3 columns, and so for that, the transposed matrix would be 3 rows and 2 columns because you are swapping rows to the column. So basically, you are taking the first row and then you are making it the first column in the transposed matrix. Then you are taking the second row from the matrix and you are making that a second column in the transposed matrix. So I think that's it. Now, before writing the solution, let me just maybe think about it for a bit. So, what can be done? We are given a matrix, and we'll just take this, or maybe we'll delete this row. So it will be 2 cross 3 matrix. So we can get the output, because for a 3 cross 3 it will be the transpose matrix will be of the same dimensions as well. But for this this original matrix is 2 cross 3 and the new one will be 3 cross 2 because they will be swapped. So yeah, so first of all, I think we can create a new transpose matrix, and then maybe we can iterate. Maybe we can maybe we can iterate over the original matrix, and then okay, so we can iterate over the original matrix, and then what can we do? So let's say we are at this first index, so we'll get that, and that will be too many for loops. So wouldn't it be? Okay, I'm not really sure. Let's say int. Okay, I should not be cheating, to be honest. Okay. So what they are doing, I thought, I saw that. Anyways, let's just. Yeah, first of all, that can be done. So the transpose matrix is created, which will have the rows will basically the rows of that one will be equal to columns of this one, and the columns of that one will be equal to rows of this one. So we have created a new matrix. Now let's just int I is equal to 0. So we are trying to iterate in the original matrix. matrix dot length I plus plus, and then again a for loop int j is equal to 0. So I'm not really sure if there is another way, but all that's coming to my mind is brute force for right now. So yeah, we can basically exchange the elements like that, and we can say transposed of j I will be equal to matrix of ij. So so let us dry run in our head, I guess. So for I, it will be, so for 0 0 transposed of 0 0 will be same. Okay, so that's okay. And then it will be 0 1. So transposed of 1 0 will be equal to 0 1. Okay. And then the transposed of 0 2 will also be equal to transposed of 2 0 will be equal to 0 2. So that will take this first row. This will make it, so it will make 1 as 0 0th element. It will make 4, which is 0 1 element, but it will make it 1 0 element. So it will be right below the 1. And then it will take 9, which is 0 2 element. So that's the last element in the row. But it will make, in the transpose, it will make it as the what? As the third element in the first column. So that should do it. And I think that is going to be the brute force approach. But anyways, regardless, we can just okay, so we can, I think, just print it out here only. Transposed matrix. Okay, so for printing also, I think we need to, iterate and do all that. And for G also. Okay, let us just how were we printing it? We had written a function for it, right? If I'm not wrong. Transposed matrix. How would we print a matrix? Wow, what an interesting question. System. Yeah, okay, that's it. But that is too much, don't you think? That's like running 2 for loops here and then again here. I'm not really sure what will be the time complexity of it. Let's just try it. At least it's a solution. Okay, we need to call that function here. Let's say transpose of R matrix. Just clear it. Okay, maybe we can give, no, maybe we can give a next line here. Yeah. Okay, so that prints the matrix like how we intended. It prints 149, which was the row of first matrix, and it prints it as column of the transposed one. And then 1143, which was second row, but it is printing as second column of the transposed matrix. So that is my brute force approach to that. Now I'm not really sure if it is the best or optimized solution. Although let me just check it. So there are only 3 questions, I think, here. Yeah. So if it is correct, then we'll be done for the day. And if it is not, then obviously we'll have to. Okay. So it is pretty much the same. I mean, the logic and everything is the same, but yeah, the additional steps that they have taken is that they have just said, okay, so basically what they have done is they have not done this here and made a public static void print matrix and made it as a function. I think that's cool. That is something we can do. So we can just okay, and here, okay, so they have done like, yeah, basically they have printed the original matrix as well, and then they have so yeah, I think we can do that. Let's just print matrix as this, and then okay, so yeah, we need to call this one here. No, not here. Here, so that we can access and print that. And we can just remove it. No, we should be calling it. Obviously, we can't remove that. So yeah, for better optimization, maybe they have done like intro is equal to this, column is equal to this. So new one will be column here and row here, and here also row and column. So okay, and then we are calling the print function to our transpose matrix. So let us just say this line right here. Okay, I think we are good to go. And yeah, that's clear. Okay. Okay, my bad. We need to say matrix dot length, which we are giving as an input. So yeah, this is system dot out dot println original matrix, and then I think, yeah, let's just remove that from there also and just paste it here. Original matrix, transpose matrix. So yeah, that is good enough, I guess. And So basically, additionally, they have not created the function for this transpose. Where they have just defined it right here. But again, as I said, to see and evaluate these things, like this was different, this was different, and yeah, I think we can call this print count. Okay, print sum, transpose. The equations that we solved in class were like pretty pretty nice, I guess. I don't know what to say it. Yeah, so basically, okay, I'm not really sure where is the main function right here, because I've commented this out and then I'm just making new functions. Okay, say here it is. So basically, first we did this spiral matrix. In that, basically, you are given a matrix, and so you are supposed to find no, not sorry, you are supposed to print the elements in a spiral fashion. So like go from the first row and then the second, then the no first row, then top row basically, then right part, which is right column, bottom row, then left column, and then go inside, then move to like the second row, and then yeah, so like that. So this was the function for that, and what we did after that. Okay, so we also did diagonal sum. So first was obviously the brute force way, which was just to iterate two for loops, and so diagonal primary diagonal has a special property that I and j are are same in it. So yeah, that was about that, and no, okay, I got distracted because I was getting a call. My bad. Just a second. Okay, I think that's fine. Anyway, so yeah, for the primary diagonal, we have that condition, and then secondary diagonal, we have a condition that it was always like the sum of I and j was always one, like length minus one. So that was a pattern for all the diagonal elements. So yeah, then we sum that, but that was kind of brute force, of course, because it's big of n square. But now there was a second approach, which was this one, which is that we can just uh, we can just iterate in a row, and then we can go to the primary diagonal, and we can say sum will be plus of equal to matrix I and I, because obviously it's same, right? So wherever they are the same, just add them into the sum variable. And for the second condition, there was a pattern. So basically, yeah, if I plus j is equal to matrix dot length minus 1, then what will be, okay, have I made a mistake here? I think I have. So it should be if I is not equal to matrix dot length minus 1 minus j. Yeah, so I think I had made a mistake there. So then sum will be equal to this I, and this will be the j. And that is, we are doing that because in this primary diagonal there will be like the middle element, which will if it is odd cross odd matrix, then there will be a middle element which will be counted twice if we do it here and here as well. So we are just avoiding that case, like if both are equal in the secondary diagonal, which will only be in that middle element. So in the secondary diagonal, when we traverse like that, so the middle element will be where this I and j are equal. So we have excluded that. And anyways, so then there was this interesting thing which was staircase, kind of. And that was basically you have to search in a sorted matrix. So let's say this is the sorted matrix, and it is sorted row wise and it is sorted column wise, as you can see. But so yeah, there was, again, the row will be matrix dot length minus 1 and the column will be equal to 0, because if we are starting from this element, then row will be okay. Okay, so I think I have altered this and then written a different thing here. Basically, it was given in the homework that so if you start from this element, so these are special element in this case, because this element has row number 0 and column is equal to column minus 1, number of column minus 1. So while so if we are iterating through that, then we can just do when row is less than equal to less than matrix dot length and column is greater than equal to 0, and if we find the key right there, then we can just say that we found it. Else if in this case, which is given right here, which is that we are starting from here, so which is column equal to 0 and row is equal to the last row. So if we find it here, then obviously we can say key found. If we don't find it, and if that element is less than key, then we can just move to the right side, because we know that there are elements on the right. And if the key is greater than, if the element is greater than that, we can just go up, because our key is less than the current element and we know that there are smaller elements on the upper side. So that's it. And if we were to do reverse, that will be if we start from here, so that will be row as 0 and column as column minus 1, I mean last column, whatever. So then we will say that while column is less than matrix dot length and row is greater than equal to 0, we can just if we find it at that point, then we can just say key found. And here, if it is greater than, like if our key is greater than this element, then we can just move down, which will be row plus plus. And if it is not, if it is less than, our key is less than the current element, we can just move left, so which will be column minus minus. So that will give the same result, and we would find our I think the time complexity for this was n plus m or something, if I'm not wrong, and if I am remembering correctly. But anyways, that was it for 2D arrays. I have not started with the chapter yet, which is the next chapter, which is about strings. Although I think I should start with it as soon as possible, ASAP, because tomorrow I'll need to finish the strings chapter, then only I'll be able to do questions in tomorrow's video. So yeah, I think we finished early today, so I have some more time. I think I'll utilize it to do the project work, and then in the night I'll just cover some lectures about strings and then be back tomorrow. So today I was able to do this in this evening because I had no lectures to do beforehand. Tomorrow I will have lectures to do about strings, so yeah, I think we'll manage it somehow. But anyways, let us just wrap it up here. While it is still while the sun is still up, I think I need to go running soon or walking, whatever. And yeah, anyways. So that's a wrap up for today. It was day 10th. We are moving into the double digits. We are moving into double digits now. And I don't know why I'm fumbling today. But, anyways, we have completed 10 days successfully. I think I'll just upload this here now only, or maybe in the night, so that the consistency is kind of maintained. I think I'll upload it in the night, anyways. So, yeah, that's about it. Signing off for today. And if you watch till here, have a great day or night whenever you are watching this. So, yeah, signing off. Bye bye. We'll see ya tomorrow with strings, hopefully. Okay, so bye bye.